All right, hey Erica, this is section 3.2. This is translations. This is even easier than what yesterday was. And the homework assignment will take you not much time at all. Translations is what this guy is. Aside from a translation being like a language thing, in math, what are translations? Like you're sliding things, okay? So I'm going to put a slide next to it because that's what that means. Translating something just means you're sliding it into a different spot, okay? I'm going to also put an arrow next to this. I'm going to say it's also a congruence transformation, just like yesterday. Just like yesterday when we had reflections, it's a congruence transformation. What's that word congruent mean again? Same shape, same size, right? So as I am doing this, I need to make sure that as I'm moving it or rewriting it or whatever, it is staying the same shape and same size. And if it's not, I did something wrong, right? Okay, same shape, same size. So all of these things, reflections, translations, they should stay same shape, same size. Okay? All right. Same. Shame. Well, you're putting shape on there, so shape is SH.
My M is an N, so it's actually shame.
Shame. So what they will have you do is when you're doing translations, you'll have what's called a translation vector, and that will show you the direction and how far you're moving it, okay? So according to this is my translation vector. This guy is vector W. It doesn't really matter what the name of the vector is, but this guy is W, and you see like this little hook over top of it. It's kind of like an arrow, but missing the bottom half of the arrow, right? Like he doesn't have that part of the arrow. So that's kind of just what the vector looks like. It's just saying we're sliding him to the left and up slightly, going that direction, okay? So that's this vector. They will, when they start to do coordinate planes, they'll talk about translation vectors as being like this notation. They'll use that notation, okay? So translation vectors, we're going to first draw them, and they give us the translation vector. It says copy the figure in the given translation vector, then draw the figure along the translation vector. Okay, so we've got this, and we are going to transfer him. Okay, you're going to take your note card. Let me show you how you're going to do this. This part you have to do a little bit of eyeballing. Okay, so what you're going to do is you have your dots Z, X, Y, and you're going to position your note card so that you have it like this. Okay, so it's going through Z, but you want this bottom side to be parallel to this guy. So that's where you have to kind of eyeball it, right? So you want to put the note card above so that you can still see that it's visible, right? That line is visible, so you can eyeball whether it's parallel or not. So your note card's going to go through Z and parallel to that guy, okay? And you're going to just extend this line out right here. You're just going to draw this line right here, extending that Z out, okay? And you're also going to use your note card as a measuring device because you're going to measure the length of this vector and move your Z over that length. Does that make sense? Yeah? Okay. So you're going to do that for X, Y, and Z. So for X, you're going to put your note card something like this. I'm trying to draw this on the computer so that Erica can kind of see what we're doing. You're going to just put your note card so it's parallel to this line, right? The bottom of your note card. And your note card's going to look like this. So you can extend this line out a little bit from here to here, right? Something like that. That's kind of hard for me to explain when on the computer. But anyway, so Z, you think you got it? My Z looks like that. X.
I didn't do anything else.
Looks like that. Y.
Goodness.
Looks like
Okay, so you extended to the C.
that-ish.
Yeah.
Yes. So then you measure, you measure this distance from here to here, and then you're going to mark that off. You eyeball the parallelness, yes. I know, it's kind of hard. You eyeball the parallelness. Okay, and then I'm going to do my distances. So I've got parallelness. Y. We're going to make it so it is. Right?
The things that we learned in this class.
Z. You guys are, oh no, now I just screwed it up. Whatever. I just zoomed it in and out.
You guys are what?
What did we name the little box in the right angle thing again?
It had a name.
Wasn't it? No, we named it Steven. Yeah.
When?
What thing?
The little...
The 90-degree angle box. So we name him like Steven or Charlie or something like that.
Well, I probably wasn't paying attention.
Okay, make sure you label these X prime, Y prime, Z prime. There they are. What did Kyle call him this morning?
Kyle's Kyle.
X. He called him X, Y, and Z.
It's parallelism.
No, what did he call him? Remake. X remake, Y, I don't remember what it was. Remake. I don't know. Something like that. Something like that. So anyway, did he stay the same shape, same size? If he didn't, you did it wrong.
Probably.
You didn't do it right. Okay. Same shape, same size, roughly about that. Okay? Happy with that? Not too bad?
Like that. Mine's a little wonky.
Okay.
The connected lines.
Let's go down to this next section. You have 3 coordinate points. 1, 2, 3, E, F, G are those guys. And then they give you this thing right here, and this tells you how far and in what direction you are moving it. Okay, that's called a translation vector. Translation vector. Translation vector. That's what he is. Okay. Now, the numbers inside of there tell you how you're moving it. So what's the 2 gonna say? Do you think?
Up to.
No. 2 is in the X spot, right? Okay. So the first coordinate is the X's, and if we're adding 2 to it, this means we're going to the right 2. Okay. What about the 5?
Up 5.
Up 5. If that was a -5, it would be down 5. If it was a -2, it would be left 2. Does that make sense? Right 2, up 5. Okay. So we're gonna go ahead and I'm gonna do this without graphing my points first. So whatever, it's fine. It's fine. E, F, G. I'm going to put these points over here. -7, -1, -4, -4, and -3, -1. And we're going to write what these points become, okay? So, starting with, I'm going to find E prime. Starting with -7, -1, if I move him 2 to the right and 5 units up, you're literally just taking -7 and adding 2 to it. So it would be -5. You're taking -1 and adding 5 to it. 4.
I went the wrong direction.
Did
That's
you just
okay.
say -6?
All right, -4, you're adding 2 to it.
-2.
-2. -4 and adding 5 to it. 1. Now you guys are scared to answer because I know Jalen especially is scared to answer because she's like, oh, I want to. All right, -3 adding 2 to it. -1, comma. 4. There you go. Now she's, look at the confidence. All right. So I'm just going to plot these guys and we're going to see how he is moved. -7, -1. And I'm really, when I'm doing this, looking to see whether or not he stays the same. There you go. Jalen, really? Come on. Same shape, same size. Here we go. I know. You're just. All right. There he is.
I'm not done yet.
-5, 4, -2, 1, -1, 4. He is the shame. He is the shame. Same shape, same size. There he is. Right there. There he is. Okay. All right. Now this time we have 4 points in the next example. Are we ready to move on?
Yep.
J, K, L, M. I'm going to write those guys down. 3, 4, 5, 2. I don't know. I just have to organize my stuff over here. And 5, 6. Okay. How are we moving him? What's this say?
Left 3, down 4.
Left 3, down 4, because they are negative. Left 3, down 4. The first one is the X coordinate. That tells you left and right. The other one is the up and down. That's those guys. Okay. Left 3, down 4. So, J prime, if I go left 3, down 4, from 3, 4, it's just like you're combining. 3 minus 3 would be 0. 4 minus 4 is 0 again. K prime, L prime, M prime. Okay. 5, 2 will become 2, -2. 2, -2. 7, 4 becomes 4, 0. 5, 6. 2, 2. Okay, so I'm going to plot my beginning, plot my end, make sure that he's correct. 3, 4, 5, 2, 7, 4, 5, 6. He makes like a little square, kind of. Oh, wait a second. 5, 6. I'm not in the right spot. It's like a diamond, but it is a square, I think. Like perfect. Well, my diagram's not going to be very good.
Is Maya just expecting people to just give her money?
I don't know. I don't know what her thought process was there. But anyway.
Good thought process.
Yeah, I know.
Fine.
There's people that do that.
Do what?
Like when it's their birthday or whatever, they'll walk around like Lincoln and they'll have like they'll take T-shirts and they'll have like their Venmo whatever thing on it and they'll say it's my birthday, give me
And what,
money,
they make,
and people will actually send them money.
they'll make $80 when they could have just
Yeah.
gone getting a job and made $180.
I don't know.
But with free money.
I'm gonna
Like,
do that
the
for my
same
birthday.
amount of labor, just walking around, you could make
But
twice as much.
free money is free money.
I
Yeah,
think
why
I-
are you
Anyway.
in here?
Okay,
You guys
there's
want
that.
to help me with filing?
Okay, moving on, next slide. Next side, they have just one example, and then this is it. We have a marching band, and what's happening is we are starting in position 1, and we're going to position 2, and then we're going to position 3. So it says, describe the translation of the trumpets from just position 1 to position 2 in coordinate notation and in words. So from position 1 to position 2, I'm going to zoom in so we can see. Now don't go by the boxes because they're going by twos, right? So it's very confusing for me to look at the line as a whole. So I usually pick one point. So I'm going to pick on this guy that's on the end here and figure out where he goes from here to here, okay? If I pick on that top guy, he is at, is this 14 right here? If we're going by twos? He's at the 14 mark, and he goes over to the 2 mark. So how many are we going to the left? 12. We're going 12 to the left. So in words, this would be left 12, okay? In notation, they're wanting that vector.
-12.
It would be -12, comma, what?
So
We're going just from position 1 to position 2. Just from position 1 to position 2. 0, right? We're not going any on the first part.
Instead of like the parentheses, you did a triangle thing.
Yes, when you're talking about so the triangular brackets, that is when you know that you are moving it. So that's the translation vector versus the parentheses. Parentheses in an ordered pair. The triangular brackets means that's how you're moving it. Okay. Woo. I don't know what just happened. All right. Now from position 1 to position 3. Position 1 to position 3, we know that we've gone over 12. But then we have to decide how far down he's going. So up here, he's here and he's going down. He's going down 9, right? Like each box is 2. So 2, 4, 6, 8, and then a half a box would be 9. He's going down 9. So I'm going to describe that in words as left 12, down 9. Or Chase was like, it's left 12 and backward 9. I'm like, whatever, Chase. I don't really care. Anyway, because he's like, technically, that's what that means. So left 12, down 9. And that in triangular brackets in the coordinate or the using a translation vector, that's this guy, okay? What would that look like?
-12, comma.
-12, -9. Yep, with the vectors.
Are you done now?
Yes, there he is.
No.
Good? Happy with that? Okay.
Wait, wait, house.
I'm going to give you your homework assignment and then I'm going to explain one thing because it's kind of weird on your homework
How
assignment.
about Nova more? Why does it look like that?
Filing.
Lickety-split.
Oh yeah, you already did.
This is so lickety-split. And they
Filing
totally helped
and
you out on
amendment
this
for
homework
setback.
assignment.
Yeah, we don't have to do the Nova thing.
Take a look at this one. On this side, there's 4 problems. But check it out. This was very confusing for some people because look at it.
So many arrows.
Hold on. They want you to move it this way. And they've already given you the arrows. So this is where M lives, L lives, O lives, N lives. You're just connecting the dots. So on this page, they give it to you. That's so nice. You don't have to draw your arrows. The other one has 2 problems, and you do have to draw those arrows yourself. But this one, they basically has 4 problems done for you, so that's exciting. Anyway, so there's that. Okay? Some people saw that, and they were like, what? I'm confused. How do I do that? It's just given to you, basically. Okay? So they've done part of it for you. Okay? Actually, I went over that. I didn't even give him an opportunity to be confused because I just told him that right away. But in past years, they would come back and they would be like, you didn't tell us how to do this. Well, yeah, I mean, they're just giving you half of the problem.
Jalen,
So anyway.
do you know what?
All right. Bye, Erica.
72